Hey guys, welcome back to my channel. UM here. So let's continue with the series of three challenges that I just saw in the previous one. So this is the second one because we were solving the challenge related to the continuous subarray. Then we solved one of the solutions, and the solution the guy was suggesting to do these three challenges, so you can watch what we did on continuous array video, and yeah, we did yesterday the longest substring without repeating any value, and now we are going to do the min stack. Yeah, so let's see. So so let's start. Let's get started. So design a stack that supports push, pop, top, and retrieving the minimum element in constant time. Implement the min stack class. So we have the min stack class here. Min stack initialize the stack object. Just to remember, the stack is the one that the last that was attached, right? It's the first that will be out. So every time that we push something, when we pop, it will be the first one, right? So minimum stack initializes the stack object. Void push into ball pushes the element ball into the stack. Void pop removes the element on top of the stack. Int top gets the top element of the stack. This is obviously in C++, I guess, or Java maybe. Uh, anyway, int getMin retrieves the minimum element in the stack. You must implement a solution with O big O of 1 time complexity for each function. Okay, okay. That's interesting. So, so for push, pop, and top, it's big O of 1 already. So it's okay. But for the get me, this one is interesting. Hmm, Interesting. So example, input min stack push get me pop top get me. So min stack push -2 push 0 -3 empty. Okay. Then we have this explanation. Push -2 push 0 return -3 get me return -2. Value it's between -2 powered by 31 and 2 powered by 31 -1. Methods pop, top, and get me operations will always be called on non-empty stacks. Okay, that's good. And at most 3 times 10 powered by 4 calls will be made to push, pop, top, and get me. Oh, that's a lot of calls. So that's why we need to do it on big O of 1, right? In order to improve Okay, your min stack object will be instantiated and called as such. Object min stack push vol object object dot pop ret 3 is object top, ret 4 is object get min. All right. So first off, we need the stack, right? Because um, we need to retrieve this data somewhere. So it will be int, and we need to initialize that. So let's do it like that. All right. Uh, so now let's run just to run. Okay, yeah, it's missing these things right here. So let's do the other ones. I think it's easy. Uh, so pop will be pop less, right? Simple. Top will be um, like return stack dot count minus one. This will be the top. Push will be just append all. Okay, we don't need to run over the stack. This let's just return zero for a while. So right now, if we just play that, okay, okay, you have two get means that it's just returning the wrong one. All right, so the get mean we cannot run, cannot iterate through the stack, right? So we need to have this information. We need to already have this information without searching for it. So the minimum value, it kind of depends on whatever we push, right? So for example, we have a stack of, I don't know, let's get one example here. So, okay, let's see. So minus 3, minus 2, 5, or 3, 4, 5, or even 5, 4, 2, 6. Let's say like that, right? So when we push one information, so we're going to push minus 3. So what will be the minimum value when we have here? It will be minus 3, right? Because we just have this information. So minus 3, we have just minus 3 on stack, and the minimum will be minus 3, right? So if we do it on the minus 2, so it will have minus 3, minus 2, and the minimum will be minus 2, or minus 3, right? I mean, minus 3 is less than minus 2, right? Yeah, it is, right? So it's minus 3. Ah, it's minus 3. Oh, because it popped, right? Okay, yeah, yeah. Never mind. Sorry, guys. Okay, so if we, okay, so we have the minimum here, So now we can push 5, for example, and then we're going to have um, -3, -2, 5. And with that, we are going to have the minimum that will also be -3, right? Yeah, for these cases, we're going to have only -3. So -3, we needed only the minimum value. So basically, we can get like var minimum value, right? We can store that. That will be an integer. And I don't know, for just to start, we can have it like minimum value equals to int.max. And then when we push something, minimum value will be um, between minimum value and vol, right? And then we just return minimum value. Yeah, I think that's it, right, guys? I think that's it. Let's run. Okay, what? -2, -2. Oh, because on pop, we are not getting the previous values, right? Yeah, because I mean, if we have 3, okay, so on pop, we should then run through the entire stack again, right? Mm, like, what if we do it? Okay, so for example, if we have -5 here, so it will be -5 instead. 3 -2 -5. Then here at this point will be -5. But if we pop it, this will not have it anymore, and it will be -3 then. So we might actually have to stack this thing right here as well. We need to create a stack for this one as well. So minimum value stack, I guess we can call it like that. And then these will be like that, right? And and right here, minimum value and minimum stack dot count -1, right? Yeah, it's minimum value stack. I mean, let's min value will be between val and minimal stack this, right? Then we are going to append the min value. Did you guys get it? So right here, I'm going to check the latest value that was stacked in min val stack. That will be essentially this stack right here. I will be stacking this. So I'll be always comparing the last minimal value that we had, and I will be stacking for each level of the stack that we have. So when we push, we're going to also push minimum value stack value as well. When we pop, we're going to pop that as well. So then we have everything updated. So for this one, we have minimum value stack, minimum value, okay. And then we're going to append the value. Okay, that's it, I guess. When we pop, we need to pop last as well on minimum value stack. When we're going to top, it's the same. And the minimum value will be minimum value stack, minimum value stack dot count minus one. And I think that's it, right, guys? Okay, what's going on here? Back tracing, crash illegal. Okay, what happened here? Ah, okay. So for the first time that it will be pushed, minimum value stack will be empty, right? So there's no last item. Interesting. Okay, so I'm going to call minimum vol stack item like that, and or maybe last minimum vol stack item, and then I'm going to check. So if let minimal stack, or maybe we can even do like that. So guard, yeah, let's do it like that. Guard vol stack dot count. It's upper than one, right? Else we just append and return. Otherwise, we will get the minimum value. Um, in here, we're going to append the value. We're going to append both stacks. And yeah, there's no return, right? We just do it like that. I don't know why I'm returning here. There's no return here. Um, yeah, I think that's it, guys. Let's try it out. Okay, what happened here? Okay, what? It's returning zero right here. Um, let's print that out. Print. Let's debug it. So we have push operation with the value vol. Let's do like that. So push vol and then we have the stack, right? Um, we have the stack and the minimum value stack. Let's see, right? The same goes right here. First push, let's call like that. So then we have the pop, then we have the top, then we have the get me, that is just return. That's right. Let's call it that. Let mean value be like that, and this will make it more readable for a while. All right. All right. That's right. Let's see what is going on here. What? Okay, so we did the first push with -2. Oh, right. I get it. So it's higher than 0, right? Not higher than 1. Okay, this was just one of the things. So we pushed 2, -2, -2, -2. Okay, then we pushed 0. All right, 0, 0, -2, -2. Okay, then we pushed -3, -2, 0, -3, -2, 0, -2. Okay, then we called get me, that is -3. Then we call pop. What happened with the pop? Okay, let's do like that. Pop. Let's see like that. And pop stack. What's wrong with that? Get me pushed. Okay, so we have first push, that is -2. Push. Is this is the example, right? So first push 0, push -3, get me, and then pop. Something's going on with the pop, but what's going on with that? Let's Good. Oh, I forgot about this thing on Opera. Okay, what's going on? I don't get it. So it's not on pop, right? So if it's not on pop and it's returning get me, so it's get me doing this return. Oh, yeah, I got it. So the thing is, we were, yeah, now I get it. Okay, okay, okay. Let's run again. Okay, so it worked. All right, it worked, right, guys? Let's comment all the prints and then we can run. So let's remove this one. We don't need this one. This we don't need. Oh, the print was behind the top. Okay, that doesn't make sense at all. But anyway, so let's play again. Okay, it's passing. So let's submit then. Great, great guys, we did it. So it beats 100%. That's good as well. 0 milliseconds in runtime. That's good. I don't know if that's real, but anyway. Um, I don't like that much to work with two stacks. I think this is weird, and so every time that we push something, we need to every time that we update the stack, we need to update the minimum value as well. So this kind of can lead to an issue uh, if we have some wrong logic around that. So maybe we can use one stack only in order to improve it. And for that, I think we can have like stack, like we can have like that value. Let's say value int and minimum value int. So on Swift, I know we can do it like that. So for that, we can not use these anymore, not having these anymore. For this one, for push this one, we can always checking the stack instead of checking everything. So if it is, we can push it like that. Well, and well, push to roll as well. And for this one, we can always use only the stack, right? Like the mean value will be like that. Stack dot count dot mean vol. And then we have already these. We don't need to append all of that. we have to and involve maybe value. Great. Then we can have only the stack here. Then we can have like this one dot val. Then we can have this one stack dot involve, right? And yeah, let's remove those strings because it's already outdated. So we can remove it. And here we have only one stack. Let's run. Let's see how it goes. Okay, it's accepted. And let's remove this example. And then we can submit. Okay, yeah, I think it's not the greatest anymore. It's 48.19%. I don't know about that, but anyway, let's submit solution. Anyway, let's submit again. Let's see. This is kind of weird, right? Because every time just, yeah, it just depends on the internet and depends on some, I don't know what is the algorithm for this. Okay, yeah, this metric calculates the function's runtime effective from 2024, 10, 19. So the mentions made before this date will remain unchanged and will be ranked along with the new data. So I don't know. See, we get 100% and zero with this implementation. So don't trust that much on this in lead code because it can misleading you to uh, think that you have done better or not, or you have done worse than most of the people. But this is not really trustable. Try to just understand what you're doing and try to see the big O of what you're doing. For example, here we can see that the big O is one because we don't need to have an iteration loop like while or a for example. So we can just um, append and popping, so push and popping, right? And then we already have the minimum value on each level. So in the memory, it will be big, a little bit more than a little bit bigger than it will be if you just run, if you iterate through the stack. But if we are considering the time, that is what the challenge it's just asking for. It needs to be considering the time because it will be called this number of times, and it's a lot. Then it doesn't matter if you just consume a little bit of more memory using like this into the stack. So the time it will be way easier because it will be just one um, every time that on the last part of the stack will have the answer that you need. So the value and the minimum value of the data. So that's it, guys. Tomorrow I'm going to solve the latest challenge of these three to understand the solution of the continuous subarrays. And it will be the sliding window maximum. So that's it. Yes, that's it. I see you tomorrow then, and please subscribe, share, leave a comment, and I don't know. If anyone wants to give an opinion about that or maybe recommend some content here, I have some ideas like I mentioned in the introduction video. I don't want to extend that much, but I have some ideas of content like I'm preparing some videos to bring here, starting new projects, starting um, commenting some new tools. So please comment here what you want to see here. And yeah, I will be always watching and receiving this feedback. So thank you guys for the support and see you tomorrow then.